Hi, we're still continuing with Chapter 5, or Lecture number 5, and we're continuing with spatial queries in GIS. We previously talked about aspatial queries. Now we're going to talk about spatial queries. And you saw before when we looked at spatial queries, or aspatial queries, we looked at the fact that we were looking at tables. Okay, give me population greater than this and less than this, or whatever we want to, or. Here we're going to combine where are different things located. And you can see we're looking at some GIS data here. This is some utility data of main, um, water lines, okay, connected to buildings and water sources. And this is some pretty powerful stuff here. Might be some things you work with as a GIS analyst if you choose to go in that direction. When we look at spatial query, it's retrieving data from a map theme. Since these features are spatially related to each other, and this is the stuff that you can't do with an IS information system by working with the map features in real-world map distance. It's the interface to our attribute database. So we can't do this with our Excel or Access or any of these other things that people might want to do them with. There are different ways that we can select things. We can do a feature selection by cursor, by graphic, or by a spatial relationship. And the by spatial relationship is probably the most powerful one. When we select by cursor, it's pretty easy. I can just grab things. Okay, and I'll show you an example here in a second. But using the individual cursor or using a particular area. So you can see up in my tools, I can just literally grab this. So that means it's activated, and I can literally just highlight on something. It'll be selected. Okay, same thing here. I can just grab my cursor, select features over here in my toolbar, wherever it is, and just grab them literally. Okay, I can set selectable features and a lot of other things within ArcGIS if I want to. I can select things by graphic. Okay, and you can see I can graph with lines, circles, boxes, polygons. So I can just draw a box around something and make sure, just pick everything that meets this box or intersects with this box. Okay, I typically don't use this within a line or a circle or a box. Okay, I can draw, this sort of ellipse right here, and let me find everything within this. It's neat, powerful, but I haven't found it to be too useful. And I can select by graphics. To me, the most powerful thing is spatial relationships. The different types of spatial relationships that we have are containment. Things fall within other things. Points fall within a polygon. How many crimes occurred within this census tract here? This is very powerful. Intersection. How many features intersect with other features? How many roads intersect with other roads? Or how many states does an interstate highway go through? Proximity. How close is something to another thing? So I want to find out how many miles or how many crimes occurred within a quarter mile of a school. And then I can break it down further to look at those types of crimes. And they have to have logical spatial relationships with each other. Because think about it, we have points, lines, and polygons. And points are dimensionless, meaning they don't have a width or length or perimeter or anything like that. So they mark an exact latitude and longitude. So typically points don't intersect with other points unless what we call coincident points. They're the exact same point on top of each other. So we might have two crimes that occurred in the same location, okay, same address or whatever, but it's pretty rare where we have coincident points. Points, when I click the identify button, 2 points show up. It's relatively rare. So when you run these spatial relationships, you need to be careful as to making sure they make logical sense. And like I said before, computers are stupid. If you try to give me all schools that intersect with crimes, it's going to return nothing, and there's a reason for that. Okay? They might be within 3 feet of the school or 20 feet, but that's not within. Okay, so be careful of that. When we look at the location methods that we can do, we have intersect, contained, and these are the ways that we can describe them. Are contained by, are identical, they share a point. Another thing I like to look at is share a centroid. Is the center within it? Containment, we want to find all crimes within a certain census tract. So we can select the census tract with a cursor through the table. So I can grab this census tract, and this is the one near campus. And this is what the select by location looks like. Okay, and I talk about this in the tutorial. select features from crime, and these are all the different types of criteria or methods that we have. Select features intersect, are within a distance of, are within the source layer. And then you could probably kill two birds with the same stone here. Okay, intersect and are completely contained within, probably the same thing. Okay, but intersect might work with lines and lines that intersect with each other while they're not contained within each other. So now I ran this, and this gave me every single crime that occurred within this census block. That might be pretty hard to go through and pick out by hand. Very hard to pick out by hand. Okay, and then my source layer is my census tracts. You notice here I said only selectable features. Okay, meaning that I went through the trouble of picking this one out. I only wanted to find within this. If I didn't have this selected, it would give me every crime that intersected with every census tract. And it'll probably give me all of them within the city. So be careful of those. Okay. We can do proximity. I can query crimes within a certain distance of a school. And then how many of those are drug crimes? So you can see here, I did my select by location. You can see all crimes within a quarter of a mile of a school. Here's the Early College High School. Here's Shepherd Middle School. Here's Spalding Elementary. Here's our campus, like right over here. This is kind of campus right here. This is kind of Lawson Street, and then Fayetteville Street runs right down this way. Now, this is a spatial query, but I now want to figure out how many of those are drug crimes. Where's the drug crime information found? In the table. Okay, so I went through and did the are within a distance of. I did 0.25 miles. And now I got to figure out, now I can do my spatial query. Now I can look up the table and figure out which one of these are there. Okay, I can do search for all drug crimes or do the $ or asterisk search on the keyword. Okay. So we had some school, this kind of goes through the assignment right here, combining aspatial with non-aspatial. Okay, for the exam, we'll talk about the exam in class, but you might need to describe the steps. But what is the usefulness of select from current selection, or how do we find a particular road name? Okay, and the last thing we can do is we can export these data. We have 20,000 crimes here in this database. I want to just export data. So if I right mouse click here, data, export data, I can get a subset of all my drug crimes within a quarter mile of a school, homicides, or whatever, because all these other dots are useless or superfluous. So there's some neat things that we can be aware of and work through when we do spatial data query.